Hi, I'm here to tell you about the efforts that Purdue WHIN has been doing in the area of IoT for digital agriculture. I lead the IoT Data Analytics Trust within Purdue WHIN along with Ali Shakouri, and this is work that I'm talking about which involves many faculty members, Jan Alabak, Ashraf Alam, Saeed Muhammadi, Dimitri Piroulis in ECE, Miko Kakmak and Rahim Rahimi in MSc, Bruno Ribeiro in computer science, Nancy Denton at Purdue Polytechnic, and Karthik Kannan and Anant Iyer in Krannert School of Management. This also involves collaborations with folks in the materials engineering part, John Sutherland, Martin Jun, Jan Anders Manson, and in agronomy, Sylvie Bruder and Tim Philly as well in agronomy. So I want to tell you about the big high-level achievements that we've had in this area of IoT and data analytics in digital agriculture. So IoT and data analytics involves four main thrusts. There is the sensing thrust, in which we have created many sensors for sensing specialized physical conditions such as temperature, humidity, nitrate. We've made these kinds of sensors in-house. We've tested them to see that they're giving us correct readings. The second aspect of IoT is communication. So there we have built a mix of long-range communication through modules such as LoRa and short-range communication through modules such as Bluetooth Low Energy, and made sure that this communication stack is highly energy optimized. The next piece of the puzzle is data analytics. So all of this data that we are getting from these sensors, we have to do analytics, and we do analytics both in the network itself as well as at the back end on the server side. And these analytics can be done in real time. Some of it is done in real time to make decisions, and some of it is done after the fact in order to get insights about what to do next. And all of this data is visualized using very intuitive front ends, so that anyone can go in, take a look at how the data is evolving over time, and they can also visualize the different sensors. If a sensor is down, if a sensor is not giving us the right kind of data, this can all be visualized in real time. In the region, the 10-county region around here, we've been able to go out and deploy large-scale IoT networks. So currently there are 4 sites in Benton County, Warren County, which are collecting nitrate data, soil humidity data, temperature data. In addition, we also have IoT networks deployed in the Purdue's experimental farms, TPAC and Acre, as well as in Ivy Tech. So we have an operational IoT network which really brings together the state of the art in terms of all of those 4 pieces that I talked about earlier, but now in operational environments. And the nodes have been made rugged so that they can operate for long periods of time despite all kinds of harsh physical conditions. And the reports and the data analysis from all of these IoT networks are available for distribution to existing and new stakeholders in our system.
Our farmers are extremely curious at the rate of what they're losing for their fertilizers added at the moment. And so by using these sensors, our goal is to really watch and see what they're losing, particularly with certain conservation practices that they've added. And so ideally, this would be instrumental in understanding what kind of things that can be applied to their management systems in order to really save money and, of course, be environmentally friendly down the road as well, by watching and seeing different weather events, and then, of course, things such as cover crops and buffer strips and how those can affect and change it, which is why we're excited that we're trialing those in a variety of different fields and farm areas to really be able to see that difference.
In terms of IoT testbeds, we have innovated on the sensor side, we have innovated on the communication side, and we have innovated on the data analytics side. So we have these kinds of sensor nodes now which package within them the microcontroller, then they package the short range and the long range communication capability, and they have adequate amount of power that they can last weeks and sometimes even months. And these nodes, they have been packaged up such that even if it rains, even if it snows, these nodes will continue to be able to operate and provide us with this kind of real-time data. Okay, so this is one of those nodes that we have developed, and this is of course within package. So this is a node which has different kinds of sensors within it, and it has the communication capability, so it's able to communicate over long ranges. So these are the kinds of nodes which are deployed in several of the farms where WHIN has deployments. And this is an example of the gateway node. So the sensors are collecting sensor data as they are deployed in the ground or right above the ground, and these communicate back to these gateway nodes. These gateway nodes are able to get the data from multiple of these sensor nodes and able to then store it, process it, and so on. So visualization has been a key focus of this work because we want this data to be available to as large a population as possible. So on a map, you will be able to see the geotagged sensors, where exactly the sensors are located. You would be able to see the real-time data as it is streaming through from these sensors and coming to our servers. For researchers, they can go in and download in a bulk manner historical data, and you can also perform quick anomaly detection on this data or really larger scale data analytics on this bulk data that you have downloaded. So the internal impact has really come about by a synergy of all these different groups who are working together, all the way from people who build these sensors to people who build the software, the embedded software that goes on it, people who do the networking and the distributed application, people who do the data analytics, and then people who make sense of this data and make use of it in their application. We have lots of instructional material that has been developed and created as part of this effort, which is being used in various classes, and we want to have this be used even more widely in the classes as well as in research projects. In terms of sustainability, we have other research grants that we have won which leverage this funding, the WHIN funding, and these grants are going to go on beyond the end of the WHIN project period, and that will help us sustain all the developments that we have made as part of WHIN. For the year ahead, we want to really double down on the progress that we have made and amplify them. So the progress we've made has been in terms of, as I said, really rugged sensor nodes, really operational sensor networks through which we can get this data, and these are operating in various farms. Now, when I say double down, what we really want to do is we want to extend them out to more number of farms and more counties, really have a very wide coverage in this 10-county region around here at Purdue. And we continue to engage with the agriculturists, with the farmers who are putting these sensors, these networks in their farms, and we want to make sure that they continue to see value from this, that they're able to get this data, process the data, able to make sense of the data, and make some changes if needed based on the data that they're collecting. So as part of this, we want to educate the local communities in order to maintain these test beds, upgrade these test beds as needed, so that we, our students, our researchers are not always doing that, and they get the sense of ownership of the sensor networks that they have. And we will certainly be a partner with the stakeholders, the local businesses, the farmers, as they take over more of the maintenance of these networks. And we want to continue to educate the community through giving guest lectures and on sensors, on IoT platforms. We've already been doing this with some K through 12 community colleges, local businesses, and we'll continue to amplify this. And also we want to test water sensors in dozens of regions, locations in this Wabash Heartland region.
I think it's a great way to continue to build the relationships we have with the farmers. We have all kinds of programs that can create all this change, but by working with WHIN and having these resources, we never would have had access to this kind of research, and let alone the material involved in that. And our farmers and the districts have really enjoyed working with WHIN and having a connection to that. It's just brought a lot more resources and capacity to what we're currently doing and the work that we're doing. It's a great addition to further all of our missions that we're working on.
So I would say the most exciting thing that we have seen through this project is this aha moment that so much of the research technology can actually be transitioned to the real world and can make a difference in the lives of people around us. And this kind of aha moment, we have experienced it, all of us, faculty members, our research scientists, our postdoctoral researchers, our students, graduate and undergraduate students. And this ability as a whole team to come together to make this transition from the research world into the practical world has been a tremendous amount of fun, given us a sense of fulfillment.